Hey guys, Mrs. Sierra here, and I'm going to be reading Building for Safety, which is the short text on our selection test today. Building for Safety. During an earthquake, buildings pose the greatest danger to people. When the ground violently shakes, a building's foundation can become loose. Earthquakes often cause buildings to crumble and collapse. Scientists and engineers have improved construction practices to better protect people from earthquakes. For example, engineers use durable materials and create innovative design plans to help ensure a building's safety. An earthquake causes the ground to move up and down and sideways. If the ground moves during an earthquake, buildings must also be able to move slightly to avoid cracking or crumbling. An engineer's goal is to create buildings that can move without falling to the ground. A building is only as strong as its foundation. Solid ground is the only safe place to build in earthquake zones. Engineers lay down a foundation only if the ground is solid. Engineers also look at how the foundation is connected to the building. If the foundation is not strongly connected to the building, an earthquake can push the building off its foundation. One solution engineers use to make buildings safer is to build the foundation and building as one unit. Another solution is to float the building above its foundation. This method uses very strong springs and pads to connect the building and foundation while still leaving space between them, which lets the foundation bend without the building breaking. The springs also absorb some of the force of the movement from the earthquake. When engineers build for safety, they use materials that absorb energy. Engineers use steel for a building's frame instead of concrete. Steel absorbs energy, whereas concrete does not. Imagine hitting a cymbal and a cement block with a hammer. The cymbal absorbs the energy from the hammer and creates rippling vibrations. Unlike the cymbal, the cement block cracks at impact. Steel helps keep the building from collapsing by absorbing the shock from the earthquake. Engineers use steel beams to strengthen ceilings and walls. The beams are placed diagonally on walls and roofs. Steel pieces are molded at angles and in a variety of shapes to avoid weak spots in the frame. The floors are joined together rather than built separately. If the building remains together, even with serious structural damage, it is much less likely to cause injury or death. Earthquake-resistant practices continue to improve. By examining buildings that have survived actual earthquakes, scientists and engineers continue to build stronger structures and protect more lives.